Then we've got our ratios. Do you have to fill those in again? Yeah. All right, fill them in. It's good old SOHCAHTOA one more time, right? Maybe if we write them down one more time, we'll have them finally memorized. Although you guys are pretty good. All right, we got them? All right, I shouldn't probably need to review them, right? Okay, so let's see what we can do. We've done this one like a million times. What's going to go on the hypotenuse there? 5, because it's a 3, 4, 5 right triangle. All right, everybody take like, I don't know, 45 seconds. Find all 6. Alright, what's the sign? Good, and the cosecant would then be? Good, and then the cosine? And the secant? Good, and the tangent? And the cotangent? Excellent. Alright, the next one says, we're going to sketch a right triangle corresponding to the trig function of the acute angle theta. And then we're going to use the Pythagorean theorem to determine the third side of the triangle, and then find the other 5 trig functions. Couldn't I find one of them without doing the triangle? Yeah. What can I find without doing the triangle? Cosecant of theta is going to be what? 3/2. Okay, now, and we've done stuff like this before. We've had to draw the triangle off of it. So we're going to draw the triangle. I'm going to pick an angle to be the reference angle, not the right angle. All right. In SOHCAHTOA world, what is the sign? What over what? Opposite over hypotenuse. So my opposite leg, right, is 2. My hypotenuse is 3. This is not 1, because 1, 2, 3 doesn't work. Okay? All right, so I have to use Pythagorean theorem, so I'm going to go, my legs are 2 squared plus x squared equals 3 squared. What's 2 squared? 4. Good. What is 3 squared? 9. So x squared equals 5. So x equals square root of 5. And it's good to put it on the triangle because I know some of us, I'm personally a visual learner, right? I have to see the picture. My daughter will ask me something in the back seat of the car. I go, I don't understand that without a picture. Because I make her do her homework in the car. So, but yeah, I have to look at it a lot of times. So it helps to have the picture. Okay? All right, what's the cosine of that triangle now? Good. So what does that make the secant of that triangle? 3 over square root of 5 and rationalize. Good. 3 square root of 5 over 5. Okay. What's missing? Tangent's missing. All right. So what's the tangent of the triangle? Before I rationalize, that's when I flip, right? So what's the flip? Square root of 5 over 2, and then we're going to go ahead and rationalize this thing. So 2 square root of 5 over 5. Yes?
Why can't there be a square root on the bottom?
It's a rule. We don't like having square roots on the bottom.
There's no real reason.
It's just when you see simplified answers, they like to not have a radical in the denominator. So I'm showing you, is it possible that maybe it's left? Sometimes. Okay, but it depends on who writes the test, and most test writers will not write a radical in the denominator. I'll look on Google and see if there's a better explanation, but against the rules. All right, let's start this one together, and then I'm going to have you take a minute and finish it, okay? So what's really, really easy to get from secant? So what is the cosine of this thing? 9/10. All right, so what in SOHCAHTOA world, secant is sha, right? Or I could go with the cosine, your choice. So what's going on the hypotenuse? 10. And then on the adjacent, I would put 9, and this is going to be whatever it is. All right, so here's what I want you to do. I want you to do your Pythagorean Theorem, find your other leg, okay? And then I want you to find your other 4 ratios. So I'm going to give you about a minute and a half, 2 minutes to do that, okay? All right, we got it? Did we get 19, square root of 19 for the leg?
Yeah.
All right, so let's see, what sign next? What was your sign? Square root of 19/10. All right, so that makes the cosecant, what? 10 over square root of 19. And we got 10 square root of 19/19, right? All right, and then the tangent is what? Good, and that makes the cotangent 9 over square root of 19, and then I rationalize that. Okay? All right, now the answer to Lauren's question, because I looked it up while you're doing the problem, okay, is back in the days before they had calculators, if you left something like that and you had to do long division to get the decimal, isn't it better to look at something like this than try to divide by something that's a radical? So that was the best explanation. Sometimes it makes it cleaner to do some work by hand. Okay, so there are sometimes a test writer will leave it in the denominator. Okay, but for right now we're going to say that it always goes to the numerator. Okay.
So it's just something they used to use a long time ago. We still have it for some reason.
Yeah. All right. This is familiar, right? Yeah, we were doing these. We've been doing these a lot, right? Because they're on our unit circle, right? They are. We've got some formulas, right? So let's practice the formulas for a minute. So, it looks like my. So what is my long leg formula? Do you remember it? Equals short times what? Okay, think about this. Short times square root of 3. It's across from the long leg, right? And then the hypotenuse equals the short times what then? 2, right? Look what's on the hypotenuse. All right, and then this one is that my hypotenuse equals my leg times what? What's on the hypotenuse? Square root of 2. Okay, so the formulas come right from the triangles. All right, so you can use. Let's see what they're doing with this next example here. It says construct an appropriate triangle to complete the table. All right. They want us to find the. It looks like they gave us the function as cosine. They gave us a triangle, the 30, 60, 90 triangle. They're telling us the degree is 60. So we're using this reference angle. In radians, we have to figure out what that is. So if you did, let's pretend you didn't have your unit circle in front of you, because maybe we won't let you have your unit circle for that part of the test. How do we convert that to radians? What are you supposed to multiply by? Do you remember? Pi over 180, good. So let's see, the zeros would cancel, 6 goes into 18, how many times? 3. So in radians, it's pi over 3. It's supposed to be like a little table, okay? Then they want us to find the function value. So basically we're looking for the cosine of 60 or the cosine of pi over 3, which would be the same thing. I could use my unit circle for that, couldn't I? So let's do that. So we could use the triangle too, couldn't we? So you pick your favorite way. Either look at the triangle or look at your unit circle. Don't yell out the answer yet. Find the value of the cosine of 60. All right, what are we getting? Nobody knows? It should be 1/2, right? Because it would be adjacent over hypotenuse. Or on your unit circle, it's in quadrant 1, right? Pi over 3 is up here, and the coordinate is 1/2 square root of 3 over 2. Okay? 2 ways to do it now. All right, looking at this one, it says that we need to we're going to go backwards. We have to find the degrees. So how do I get from radians to degrees? What are you supposed to multiply by? 180 over pi, so the pi's go away. How many times does 4 go into 180? You have calculators. 45 degrees. Okay. Which, no, big hint, it was there, right? Then they want me to find the cosecant of 45. So in SOHCAHTOA world, cosecant is CHO, isn't it? So could I use the triangle? Could I use the unit circle? It's kind of up to you. So what is the hypotenuse of this triangle? Square root of 2, and what's the adjacent, or sorry, the opposite? 1. So I don't really even need the 1 in the denominator, but it's not wrong to write it there. Okay? Alright, let's look at what's left here. So on this one, they gave us the function value, and we have to figure out the radians and the degrees. Remember, tangent is TOA. And technically there's always a 1 in the denominator, isn't there? Okay, so this would be the opposite over the adjacent. So if my square root of 3 is the opposite and my 1 is the adjacent, which angle measure does it have to be?
60.
Has to be the 60 degrees. Which, didn't we calculate that a minute ago? What's it in radians? Pi over 3. Okay. The next one we're going to write down is, I think you have to fill those in. Okay, fill those in. They are on the wall, you're right. Okay, so we have the reciprocal identities. We've been doing those for a while. And in the room, remember we talked about the windows yesterday? Those are the first window, the first column of the first window. Okay? Then we have what we call the quotient identities, and we've been working with these for a few days now. We've got the sine divided by the cosine and the cosine divided by the sine for cotangent. And again, that's the first window, second column. Then you've got the middle window. All right? The middle window's a little insane. All right? But what I did was I took these three identities and I solved it for each one of the parts. Okay? So if you look at that first one, so they're called the Pythagorean identities, because think about it, legs squared plus legs squared equals hypotenuse squared, right? It's something squared plus something squared equals something squared. But I could solve this one for sine, right? Couldn't I move the cosine to the other side? So sine squared is the same as 1 minus cosine squared. Right, that's where the other one of the other signs comes from. Or I could move the sine over to the other side. So I could say that cosine squared equals 1 minus sine squared. Okay? So we manipulate these identities quite a bit. All right? You have to basically have sine squared plus cosine squared equals 1 memorized. You will have it memorized. We use it that much. Okay? The other two don't come up as much. This one, the tangent one, comes up the second most. The cotangent, cosecant, you rarely ever see. Okay? We probably see it in here, but in calculus, we rarely ever see it. All right? So identities are all about manipulating things and getting them to be what we want them to be. Okay? So we're going to start by completing the identity. So 1 over cosine is the same as what did we just write down? It's reciprocal of secant, isn't it? Secant theta. All right. What's sine over cosine the same as? Tangent of theta. And I have a typo there. I'm missing a theta on there, aren't I? There's a typo in your notes, too. Should be cotangent squared of theta. All right. And what is cotangent squared of theta according to the formula you just wrote down? Cosecant squared, good, of theta. Okay. Do you have to fill in on the next one too? Or is it just there? It's there? Okay. So these ones are weird. These are called the... Okay. These are called the cofunction identities, okay? And if you look at the windows again, look at the third window, and look at the first column in the third window. The difference between what I have up here and what you have there is it says pi over 2, which is the same as 90 degrees. Okay, so they're there. All right. It's in radians because we don't work in degrees in calculus. So I only have the pi over 2 up there. All right. So no, it's the same as pi over 2. Okay. I didn't bring up one of your erase all. So hopefully you figured out earlier this week when we were doing the motocross ramp. Did you notice that there was a pattern with the numbers? That's what that task was supposed to get you to, is that there's a pattern with these numbers. Okay? And if you notice, if I take the 30-degree angle and the 60-degree angle, the sine and the cosine, their answers are equivalent. Okay? 60 degrees of sine is the same as 30 degrees of cosine. Okay? And that's where these identities come in. There is a relationship that exists there. So if I've got the sine of 90 minus theta, that ends up, and it ends up equaling the same value as the cosine. So that it's really saying if I've got the sine of 60, that answer is the same as the cosine of 30. These two numbers need to add up to 90 degrees. Okay? Really, that's all there is to the identities, is you just have to know the cosine 90 goes with sine, tangent goes with cotangent, secant goes with cosecant. Okay? And that's actually where we're going to stop. I thought I was going to do example 8, but I'm not. Because knowing this identity is enough to get you to finish the homework that goes with this one. Okay? Sound good? All right. I'm going to post really quick. I haven't posted today's homework yet. I'm going to post that. I'm going to post it underneath yesterday's, though. Okay? And then you've got actually a lot of time to work. I can come around and stamp again. All right. So I'm going to edit this one from yesterday. Oh, it's Groundhog Day.
It is?
It is. It's the 2nd of February.
So is it still winter or is it?
I don't know. We'd have to ask the internet. Somebody ask the internet.
I'll ask the internet. Hey Google.
Okay. Find out if Punxsutawney Phil saw his shadow. Alright, let me find this. Well, we need to know if there's going to be 6 more weeks or if it's over. You have to ask if the groundhog saw its shadow, and then what does it mean?
It's still winter.
It's still winter. The internet says it's still winter.
The internet knows all of them.
Did the groundhog see its shadow?
I don't apparently. Yes.
It says it sees its shadow.
Does that mean it's with 6 more weeks of winter?
I have no idea.
We'll ask the internet. That's what the internet's there for, right?
It says winter's still coming.
Winter's still coming. All right. If you hit refresh, I just posted today's. Remember, today's is connected to what we taught yesterday, right? This one here that I taught today will be connected to tomorrow's. I will put tomorrow's up as well here in a minute. Okay?
Tomorrow's from when?
Yeah.